Erwin Schrödinger and Werner Heisenberg are tearing down a highway in the middle of the night when flashing lights appear in the rearview mirror. A cop pulls them over. The officer walks up to the window and asks Heisenberg, "Do you have any idea how fast you were going?" Heisenberg shakes his head. "No, officer, but I know exactly where I am." The cop, now highly suspicious, says, "You were going 90 miles an hour." Heisenberg throws his hands up in despair. "Great, now I'm totally lost." Frustrated, the cop decides to search the car. He opens the trunk, peers inside, and yells, "Hey, did you guys know there's a dead cat in here?" Schrödinger angrily yells back, "Well, there is now, you jerk." To understand why that joke is the pinnacle of physics humor, we have to travel back to 1935 and look at the thought experiment that started it all. Schrödinger's cat is the most famous, most misunderstood, and objectively the unluckiest animal in the history of science. Most people assume Schrödinger proposed this famous paradox as a genuine scientific theory. In reality, he invented the scenario as a sarcastic insult to mock his colleagues' work. In 1935, the brilliant Austrian physicist Erwin Schrödinger was reaching his breaking point with the scientific establishment. His peers, Niels Bohr and Werner Heisenberg, championed a framework that was rapidly taking over the field, the Copenhagen Interpretation of quantum mechanics. It argued that tiny particles, like electrons or photons, do not possess a definite physical property or location until they are measured. Before a human observer looks at them, they exist in a superposition of all possible states at once. Schrödinger found this idea absurd. To him, the notion that the physical universe simply refuses to make up its mind until someone looks at it was a step away from actual science. This diagram illustrates superposition. Microscopically, a particle spins up, down, here, and there simultaneously. Mathematically, it exists in all overlapping states at once. But introducing a sensor forces the universe to collapse that blur into a single, definite reality. Schrödinger decided the best way to expose the flaws in this logic was to drag it out of the microscopic world. He would scale that subatomic weirdness all the way up to everyday objects. He devised a highly sinister, entirely hypothetical trap. First, you take a solid steel box. Inside that box, you place a live, healthy cat. In this schematic, a radioactive lump has a 50% chance of decaying in the next hour. If the Geiger counter detects decay, it triggers a hammer. The hammer falls, shattering a vial of hydrocyanic acid, killing the cat. Now apply the logic Bohr and Heisenberg were using. Because the radioactive decay is a quantum event, that atom exists in a superposition of being both decayed and undecayed. Therefore, the hammer is both dropped and suspended. The vial is both shattered and intact. Schrödinger's punchline was that until you open the box to check, the cat is physically forced into a state of being completely dead and perfectly alive at the exact same time. Schrödinger presented this as a mic drop moment. He expected the physics community to look at the living zombie cat, realize their theory was nonsensical, and abandon it. Instead, his colleagues ran the math, looked back at him, and agreed. They concluded that the cat really is both dead and alive. In a strange historical turn, the very example meant to sink the theory became its most enduring mascot. Schrödinger was so frustrated by this outcome that he eventually quit physics entirely to study biology. His sarcastic attempt to mock his peers provided the exact conceptual framework we still use to visualize the subatomic universe today. In the real world, you don't have to worry about your pet. A literal, physical cat could never survive in a superposition. Modern physics prevents it through a process known as quantum decoherence. Large objects are simply too warm and interact with too many things to stay isolated from their surroundings. As this diagram shows, a cat is constantly bombarded by air molecules, heat, and light. Each interaction acts as a measurement, forcing the cat's reality to collapse into a single state instantly. While decoherence keeps our everyday world free of zombie cats, Schrödinger's hypothetical scenario accurately describes how the microscopic world behaves when no one is watching. For incredibly tiny, highly isolated things, like individual electrons, superposition is a physical reality. This photograph shows the internal hardware of a quantum computer, a machine that functions only because the logic of that paradox is true. Standard computers process data using bits, which are strictly locked into being either a 0 or a 1. Quantum computers use qubits, which can exist as a 0 and a 1 at the exact same time. This allows them to perform complex calculations millions of times faster than standard supercomputers. This refusal to make up its mind is a literal property of the physical world. It means that on the smallest level, everything remains a blurred spectrum of possibilities, only snapping into focus the moment we decide to look.